environment. This panel is called Quality of Geospatial Data. I am pleased to be here with these two very well-known speakers, Antonio Arozarena Villar, and to my left, François Mascosé. As in every panel, we will follow the same dynamics. You will have 20 minutes to present, and we will end with a 10-minute Q&A session. We will start by reading the resume of our speakers, and we will start with Dr. Arozamena. He was born in 1950 in Madrid, Spain. His professional parcours is very broad. He's a topographer engineer by the Madrid University. He is a topographic engineer. He is also an engineer on geodesics and cartography by the University of Valencia. He has 2 masters, one in business administration and the second one on IT. His experience in the private sector. From 1969 to 1976, he worked on different companies related to cartography and topography. In the public sector, well, he is also very experienced. He worked at the National Geographic Institute in Spain. From 1986 to 1991, he worked in the teledetection department of the government. He had different positions in different areas, as in teledetection, cartographic planning. He also worked in the IT department of the National Geographic Institute from Spain. From 2010 up to this day, he is a consultant on IT technologies for the National Geographic Institute of Spain. As of 1995, he has worked as a professor in teledetection, theme cartography, and cartography production. He's also a teacher at the Polytechnic University of Madrid. And in research, well, he has participated in more than 100 national and international projects. He has directed different dissertations and more than 40 papers that he has published. He works in EuroSDR, an agency focused on research and information on geospatial activities. He's a member of the expert committee of the United Nations. So let's give him a hand. Thank you very much. Good morning. I will present in Spanish, since the majority of this audience speaks Spanish. The title of my presentation is The Observation of the Territory as a Basic System for Production on Geospatial Information of Reference, IGR. This is a long title, and I would like to explain and to convey in this 20 minutes all the concepts that this title embraces. Sometimes I find that there's some confusion in terms of these concepts that are not the same thing, but they supplement each other. This is the table of contents of my presentation. First of all, I would like to talk about the idea of geospatial information, and I would like to talk about geospatial information of reference. We have to clarify the concepts in order for us to provide a better service. In the public sector, this is very important. And I would like to put on the table remarkable reflections coming from different people. All these are rather simple ideas, but yet complex. This analysis of needs is inspired by the Inspire Directive, and this sticks to the to LICIGE, to the Spanish standard. Here we have three main concepts. I'm talking about geospatial information. Information is collected just once. It needs to be harmonized with the existing standards, and it is comparable within the same territory and time. This are the current territory information criteria. It needs to be homogeneous and objective. Well, it's easy to say, but something hard to do. Having homogenic information and objective information throughout the territory, we need to focus on objects, and all the agencies and final users need to be on the same page. It needs to be multi-scale and multi-specific. It needs to integrate with other databases, and it needs to be cooperative. Let's also define, well, these concepts have been there, but right now we have to really understand what we're talking about. What is referential geospace information? First of all, it gives geolocation, very specific geolocation on geospatial information. It is a geographic framework to see and understand geospatial information. It also provides with a geographic framework on what is additional geospatial information that can be seen, produced, and integrated. Without this, any other piece of information would have been impossible to produce. It has a defined update cycle and a continuous cycle. This is key. This paragraph is for the United Nations. This is what we're fighting for, and it is provided by an authorized source with legal mandate. What is reference geospatial information? Well, it's geographic names plus communication means, hydrography plus populations, land tenure, this is land cover and land use. And these are two completely different definitions. The digital models of territory and level curves. Now we're moving from 7 meters to 30 centimeters. Now this error margin has shrinked, and the lives of everyone have changed because of this. Now, reference geospatial information. Most part of cartographic agencies are essential for the economic and social development of countries. It is a tool for the creation of culture. With geospatial information, we're creating culture. These products are expensive because looks as something simple, but it's very expensive. If it's accurate and objective and homogenic, well, this is expensive. All this information is of difficult interpretation. Cartographic agencies have been more concerned on executing and on being accurate than on satisfying real needs. And what's most serious, all this takes a lot of $1,000,000 or euro, but now it turns out to be that the population gives zero value to this. So this is a very constraining framework regarding action. Well, the concept is evolving. National cartographic agencies are evolving. These products are still of difficult access in many cases. They are expensive, as I said before. Many institutes still want to sell them. These prices are constraining and are not leading to added value. The immediate consequence has been not to use these products because price is a limitation. Added value products who were made up internally by cartographic agencies don't meet the needs of the users because of the fact that modeling wasn't made thinking about the users, and cartographic narration is not accurate and is not depending on the needs of final users. Therefore, products are created, and in many of the cases these products are expensive, but it's difficult to distribute them because we haven't planned to have a massive distribution of these products. Now let's talk about the so-called IGR production system, and this is what we have planned in our institute in terms of distribution. Now let's talk about sustainable growth. This is something really simple. These are the three basic principles: the social, the economic, and the ecological sector. These three worlds need to come together, and this is what leads to sustainability. This model is based on a territory that we want to get to know, to measure, and to transform. The user is the recipient of information. The best method is the data model based on objects, the spatial resolution model. So it's users who define the contents and the modeling, and all this is aimed to define what type of images are necessary, and to put this together will bring us closer to the users. That's why we have created expert groups that deal with artificial surfaces and with different type of surfaces to shape this type of object. The modeling needs to be done taking into consideration themes and attributes created by different scale groups, 500, 1000, and all the ones that you see here, and all this taking to standardized processes. This is the quality management plan that was created since the very beginning and approved by everyone in the supply chain, research, development, and innovation. Ever since the beginning of the project, we need to stick to the technological timing of the project. This is continuous update by themes and attributes. It would take me a lot of time to explain this and to elaborate. We act based upon sizes, upon type of user. We don't work with all of these elements at once. And dissemination has an impact on users. So this is a new model of production that I've tried to summarize here so that all of you can understand it a little better. So these are three fundamental pillars: the data model, and taking into consideration the opinions of final users. This is very important. Having scale groups for different users, themes, and groups, and dissemination. And we need to take this into consideration since the very beginning. That's how we work in Spain. Now, Earth observation. One of the pillars is observation, to define what's the pixel size, the way we define it in Europe and Spain. It is there is a transparency zone. In Europe, we have the Copernicus software. Before, the name of it was a mess, and it started to be used in the year 2000. The pre-operational stage ends in September this year, and from 2014 and 2020 it will be operational, and it bases on services rendered to the citizens, not on users. So this is the subdivision of themes, as we do in Europe. We have here the classification, desirables. A great part, the first part, is what cartographic agencies produce. Better practices. Within this bracket, we have how have we developed this new plan of information, of communication. Talking about the National Plan on Observation of the Territory, what's the plan about? Well, first of all, we need to define who's behind the whole process. In Europe, this is Spain. We can go faster, please. So we have 3 administration entities, 3 groups of administration working together. The regional administration, autonomous communities. In Spain, there are 19 autonomous territories, the state administration and the central administration and the European Union. All of us have come together and have come to an agreement in terms of this new system to produce information. So this scheme took us years of discussions, and it can be divided into 3 stages. The first one, acquiring images by scale groups. Second, the transformation into databases and dissemination. And everything was agreed upon since the very beginning, not at the end. The National Plan of Orthophotography and the National Plan on teledetection and the National Plan on land tenure of Spain. So we spoke with all of the agencies and with public users. So this is the first plan, PNOA by its acronym in Spanish. It is procuring images. We have to pay once to get those images, and we came to an agreement with the Spanish state, and we made this this service free and available for everybody. We created elevation digital models along with LIDAR, and we have an accuracy of 30 centimeters. All of you knows that altimeter is very complicated, but right now we have only a 30 centimeter margin of error. Therefore, we're defining 3 groups of pixel size, 25 centimeters, and the maximum admissible error throughout the whole productive chain, and the MDE was 5 meters. And LIDAR helped us. We used LIDAR in all of the Spanish territory, and only 0.3 centimeters of error margin. So it has taken years of negotiations amongst the different entities and agencies. Now this chart summarizes everything that I've just said. We've been discussing with the municipalities, with the cadastral authorities, with the agricultural sector, with the different regions of Spain, and it took us 2 years to put together this chart. And LIDAR is the latest in terms of technology. We have different curve levels and orography tools, and we're reaching altimetric accuracy levels that were never thought of before. The Dolin identification, the forestry mass, you don't see the dolins nor the terrain. Right now, cartographers are imagining how the land could be. Now we're able to discover a brand new vision, what's underneath the soil. Now the National Teledetection Plan, or PNT, it is also something very simple. We just need to be patient. We need to acquire all of the images from satellites, and we need to purchase those images just once, and so that everyone can use it afterwards freely. Well, it is easy to say, but it took a lot of negotiations and conversations in order for us to use these images free from cost. The first phase was to purchase periodical images. We have to deal with resolutions. The first stage was to define the different scales and the different kind of dealing with the images. The second phase was direct procurement, and the third stage, as of 2014, Spain will launch 2 satellites, and this will make images easier to access. These are the different ways of dealing with the images. The last project is the so-called CIOSA, the National System on Land Occupation in Spain. This is not very automatic in terms of information procurement because it takes human intervention, and we have a set of data. If we
La escala es un 25.000.
So it's 25,000 scale. It is produced in a decentralized way in all of Spain because of the 19 different regions. It's the same data model from half an hectare up to 2 hectares. It is a consensual model. All of the administration agencies from Spain came to an agreement on this regard, and we have allocated also grades in different classifications. This is something different in this model. For every parcel, we define the percentage of occupation in every coverage and in every land use.
Adelante.
The land is divided according to the reference geospatial databases, and after that, the polygons are drawn, and this is how they're classified according to the model we've described before. It's simple, very simple. Next one, please. The geospatial information that's used as a reference serves for all of the purposes you see on the slide. It's obvious because that's the whole purpose of them, obviously. Next one. This is the co-financing, co-production, the coordination of all the public agencies, and that is a great value. This is our greatest achievement, the cooperation, not so much the data, but the actors working together. Therefore, P and OT are sustainable projects, are integrated, they are included on national and international plans, they are based on real requirements, the financing is shared, we all pay for it. Joining the club is expensive, for the public administrations, that is. We finance 66% of the central management and 34% of the autonomous ones. And we've also integrated all of the visions, the upwards, that one we define, and the downwards, which is the European Union against us. And they are collaborative projects. The 3 pillars of collaboration is what keep us alive. And not only do they keep us alive, we thrive. It also facilitates the creation of added value, and we are permanently in tension, in innovation. Very quickly. This is Geos and GM. For all of this, next one please. I have the great pleasure to communicate that this year, 2013, after having been so submitted, we've received the award for the best public service by the UN. It is the first time that Geographic Institute is granted this award by the UN, and because of this project. So what is the whole purpose of this? Could you go very quickly, because all those are examples that show what this has been all about. It's for water design, urbanism, agricultural data, for the land registry, etc. So the conclusions. First of all, IGR is the scaffolding for all geospatial information. You all understand that this is the skeleton of all things that come afterwards. And in many countries, there is a legal mandate to produce this. And I say this because many people still doubt whether it's the responsibility of the government to produce the information. a priority had to be given to what exists in each country, because if not, there would be a redundancy, and that redundancy would lead us to an absolute disaster. Now, regarding geospatial information as a whole, including the theme one, that is one of the most important contributions to sustainable development. It has 3 basic principles, which are defined by the UN, fortunately. Marisa talked about this, about the role of the UN's Commission for Geospatial group, the group of specialists. The first time we had this at the expert level. For those of us who are undergoing a crisis, we could have used it. In Spain, the crisis is quite huge. It is a way in which we can use a new model of production to take advantage of the lessons learned. And we're also promoting something that is very difficult for us to defend to the international organizations, having bottom-up information, not top-down. The model is PNOT. I'm not saying goodbye yet, huh? Yeah, bring the last slide on. It's okay. But if I may, I still have 2 minutes, right? I would like to present you a small video that celebrates and explains what I have explained in my 20 minutes. It's only 2 minutes. I hope it's better communications than my speech. If you could turn off the lights, that would be great. Thank you. Could we turn off the lights? And could you please raise the volume of the audio? It's the Minister of Promotion, the National Geographical Institute, the Government of Spain. National Plan of Land Observation. The National Plan of Land Observation, PNOT, responds to the need to get to know the land and how the land has evolved throughout time, the territory. PNOT provides basic geographical information for sustainable management of the environment, agriculture, infrastructure, emergencies, and security matters, amongst others. The PNOT is made up by 3 big national projects. The National Plan for Aerial Photography, that includes air pictures and air models of the land. The National Plan for Teledetection, that coordinates coverage with satellite images from the outer space. And then a program for land occupancy, which takes advantage of the information from the 2 later projects to define urban, agricultural, forestry areas, the wetlands, and other natural areas all throughout Spain. The users of the information are the citizens. All of the governmental agencies in Spain, the European Commission, the European Environmental Agency, the GRC, and Eurostat, as well as the big European programs for services based on geographical information, such as Copernicus. They're used for infrastructure creation, agricultural purpose, wood management, environmental risk prevention, or in case of emergencies. PNOT follows a decentralized managerial model based on consensus, coordination, and co-financing, as well as collaboration of all of the public agencies. It is organized according to the autonomous model. It coordinates the information flow from the autonomous communities all the way up to the general state and managerial level, the European Union, and the UN. PNOT is a plan that can be exportable to other countries in terms of the ends and structure and organization. It is a collaboration project between different public institutions, and it is sustainable throughout time. PNOT has been awarded by the UN, the most prestigious award granted to the public sector. The criteria assessed for the award were the way in which collaboration is handled through all the agencies, the free and access to information, economic savings due to the production of a single source of information. The idea is to provide excellent services for all society by public administration offices. Well, that was the end of my presentation. Thank you very much. We thank you for your presentation, Dr. Sarena. Now, let's move on with our panel. It's now time to introduce our second speaker, Dr. Jean-François Mas-Cosset. And I'm going to read a little bit of his bio. He was born in Montpellier, France on May 1966. He studied his master's degree on biology by the Paul Sabatier University in Toulouse, France. He has a PhD degree with a specialty of remote perception of tropical environments by the same institution. In terms of his professional experience, as of 2000, he's been a full-time researcher at the Environmental Geography Research Center of the UNAM University, and his main research line has been remote perception and geographical perception systems applied to environmental studies and natural resources, such as the monitoring of deforestation based on satellite images, the study of forestry fragmentation, the modeling of land use changes, mapping based on remote perception and geographical systems. And he's published a great number of papers in the national and international arena, many of them on the reliability of spatial data, the quality of the data. We can quote his last book, which is on remote perception on 2011, the Sensor Modis for monitoring the land. He has won different academic awards, and he's a member of different scientific societies. For instance, he belongs to a national system of researchers level 2, and as of 2007, he's been a researcher of the state of Michoacan. He's a guest professor at the Toulouse University, and he is a member of the Latin American Specialist Society on Remote Perception and of the American Photometry Association. So without further ado, let's give him a hand. First of all, I would like to thank the speakers of the event for having invited me. The subject is on evaluated the reliability of theme maps, especially the land use coverage, but it could be applied to any other type of map. Next slide, please. So as I was saying, a map is a model. It is a simplified representation of the real world. And aside from simplifying the world, the map has certain other mistakes. There are things that the map says that cannot be explained only by simplifying matters when charting. So I'm going to speak about this. I'm going to speak about theme errors, the attribute errors of a map. When you say that in the map that it's a pine forest when it is a woodland or whatever. So this is the kind of thing that is due to data collection sometimes, but recently with the use of satellite images, many times we face the problem of having spectral confusion. When we use satellite images, we try to be very accurate in defining the vegetation or the decrease of deforestation, and many times the information that we get from our spectrums, it's not as good as for that, and therefore the way we interpret satellite images convey a certain degree of error. So assessing reliability is all about this, to see how much congruency there is between the map and the things we consider as reality, the map and the territory. And since we cannot go to each point of the map and verify, we will verify some sites, some samples out there in the field or with other more detailed images to realize how much is the map mistaken, to have a map as accurate as possible. So this subject of reliability assessment in the academia is something that is becoming more and more important, especially it started in the year 2000, but it started in the 1970s or 80s. People were already concerned about this, and they had developed some very well elaborated methods for this type of analysis. However, this is something that has taken more than, it's become more relevant as of 2000. We see the number of papers published by two magazines, the most important gazettes in remote perception, and we see that there's been a remarkable increase of the papers, either that they use reliability assessment or that they are interested on the methods to carry out this type of exercise. Next one, please. Something that is surprising is that in spite of the increase of interest for reliability assessment, when 57 studies were performed this year on change, especially the monitoring of deforestation, we discovered that most of the studies published by prestigious magazines do not carry out a robust assessment evaluation. Some of them skip it altogether. And many times the assessment exercises are not very satisfying. They might be biased, or perhaps the authors do not report all of the information they had available so as to truly assess the map, whether it was correctly mapped, or sometimes they don't take full advantage of the things they have. They do not carry out all of the estimations or analysis that are necessary to go deeper into the results, to see the comparison and the contrast of field information or detailed information from the information of the map that's been assessed. Next one, please. Something else is that in many countries, and Mexico is no exception, most of our databases, geographical databases, and our theme maps, they do not contain information on reliability. So my presentation, therefore, will be organized around three axes. One are the motivations to do a reliability theme assessment, and then we will see the principles that must be obeyed to carry out a robust assessment. And finally, I would like to provide an example of how to use reliability assessment for correcting surface statistics. And I'll wrap up with some final conclusions. Next one, please. So to begin with, why should we assess reliability? It might seem to be a waste of time because in a way it's expensive. Once I've finished creating a map and I had to invest on the satellite images and the interpreters and on many other things, and many processes are involved to do the data control, the quality control. Like in the case of INEGI, INEGI is using field information to verify, to interpret the images. INEGI ties satellite images with field information within the creation of a map. However, that is not a final assessment. So some people might say, this is a waste of time. My map has already been verified by this cross-referencing, and it's the best we could do. We cannot aspire to have anything better. So it is not that important for some people to think about this. However, it is. In order to know the reliability of our maps, beyond just knowing more about the performance of the whole classifying process, just by knowing an algorithm for the classification of digital data of satellite images of the whole chain of production, perhaps, this is something that could be taken into consideration from the start, from the creation of color compositions, the visual interpretation of images, and the whole mapping or charting process. However, the information I'll get based on this reliability assessment can give me data or information that can help me in my reading. Not only will I know how reliable my map is, perhaps if there's only an 85% accuracy level, and then the 15% of the polygons are not truly depicting what they should, but beyond that, I will be able to learn about the confusions, the most common mistakes that a map will present, and therefore I will know from starts that the map is very well in conveying tropical wood forest, but that it will be very difficult for me to understand or to distinguish the type of pine or the jungle. So it is more than that. It is more than just saying it got an 85%. It is providing information on the most common mistakes the map has, and that's something I have to live with. To such an extent that we could imagine that in extreme cases, the result of the reliability assessment could force us to provide different categories that are not being mapped with the degree of accuracy we would like to have. For instance, if I see that in my reliability assessment there's a systematic mistaking of two types of pines, then it would be better to have a single category of a mixed forest instead of trying to say which one of the pine gender is more predominant. Finally, we also see that this can help us correct the statistics of surface parameters. If I know the flaws of my map, for instance, if I figure out that my map is overestimating the surface of certain categories, then I will be able to reframe this understanding on the flaws of my map regarding the statistics of surface data. If I have a map that has a bias that is well known by me, instead of using a pixel count or the addition of areas of the polygons to get the surfaces, I will be able to apply a correction, take into consideration the mistakes I've already detected. And if I use a map in the geographical referencing system, I'll have information so as to not to propagate error. When we use different layers of information, different systems of geographical information, error adds up. This through different layers, the mistake might be small in the beginning, but after a whole set of mistakes, there's an accumulation that can be severe. Even if I'm using maps that have a satisfying reliability, the final product, the final addition of the maps or the layers is going to be very bad. So by knowing the degree of mistakes in the map and how the errors are presented can help us foresee the consequences of this error in a chain of iterations in a geographical referencing system. The information on reliability is something that is more in demand nowadays. This is something that should become a standard in metadata, for instance, of an information layer. Generally speaking, what we do is that we compare the map versus the reference information that is considered to be more reliable. The ideal thing would be, in many cases, to go and visit the places and to be able to verify that what the map says is true in the one-to-one scale. But in many cases, we do use high-resolution images to obtain information in a cheaper way. It all depends on the classifying system of the map, the level of detail it has, This reference information could be air pictures or high-resolution images, or information that is observed out there on the field, or a mix of the different approaches. So here we have an example for the National Forest Inventory of 2000, in which we created the maps using LANS-TT images, what you see to the left, and the reliability study was done with air pictures, like you see on the picture as well. It is a more detailed source for us to identify what's happening. An interpreter can see the type of coverage or land use that corresponds to the different patches that we can observe. Next one. Reliability assessment has different stages, and we cannot get too technical, but we could mention that there are two important aspects. One of them has to do with the statistics. At the end of the day, since we cannot verify the whole map, it would be impossible for anyone to do 100% verification, because it would mean to redo the map once again. What we want to have is something that is more reasonable, more economic, to verify the quality of the map in selected areas, and those areas must be representative as possible, as much as possible, of the whole mapped area. So this is a statistical conundrum. How do we get the correct sampling so as to truly be representative of the whole map? When we have robust statistics, then we can assess the uncertainty that is found around the estimates, the indexes, the reliability rates. I might be able to say, well, my map has a global reliability of 82%, plus minus 3%. That is to say, by looking at the size of my sample, I will be able to relate the reliability of my estimates with uncertainty. If the uncertainty is too high, let's say 82% plus minus 15%, it could be good, it could be quite mediocre, it depends. But then we could increase the size of the sampling to reduce the confidence, the reliability interval around the figures. And something else that is also important, but it's more subjective and interpretative, we need to obtain reference field information that are truly comparable to the map. For instance, we need to think about the scale always. Many times there are mistakes between the field data and the maps at the scale of 250. But that does not mean that 250,000 map is wrong. I could go out on the field and do my sampling, as we do, of the vegetation with a quadrant of 10 times 10 meters or 20 times 20 meters, and then have a woodland with all of the elements, and the woodland won't be found in 250,000 maps just because of a scale problem of the minimum mapping elements. So the information that we need to use to assess the map reliability has to be very reliable, obviously, but it has to consider scale matters. All of the information that I observe in the field does not necessarily has to be reflected on a map, only accounting for the scale. In terms of the sampling, the only important thing is not to do a sampling that has a bias that is convenient. That is to say, we cannot limit my verification checkpoints to the most easily accessible places or places that I know of, so that it's easy for me to get the reference information, or if I have air pictures, because in certain areas we do not have that. Especially, we could not use only the sites that are within the polygons to prevent all the limit problems, the border problems, because the sampling wouldn't be representative of the whole map, the whole territory that's mapped. it will be biased towards certain circumstances where we might say that the map is better represented or not, but it doesn't represent the map as a whole. The whole idea is to prevent biases, and there are many types of samples, as you see on the screen, that are valid. A systematic sampling or a non-aligned systematic sampling, the one upright, or the simple random sampling, in which points are all random. All of them are okay. However, it is much more convenient to try to stratify the sampling effort. For instance, look at the screen. If I do a systematic sampling, the categories that do not have a lot of surface sometimes are not represented in the sampling. So what we usually do is that we stratify the sampling so as to get verification checkpoints all throughout the points or the categories, and control the sampling efforts for each one of the categories according to the interest we have in them. Nonetheless, many times something that we do not do is that we don't think that this effort that is specially meant for a certain category is going to move the statistics. For instance, in this case, I am providing too much weighting to the gray area because it has much more control points are represented than what's in green. In green, we see a greater dispersion, we see a larger area. So the whole purpose is to do the corrections of those differences in the sampling effort. Once again, this is a problem of scale. I need to be careful in the sizing of my verification site so that it truly reflects information that is appropriate considering the scale of the map. That was in terms of the statistics. It's a little bit complicated for somebody like me who doesn't do a lot of math, but that's very square. That's not problematic. The most serious type of problem we face is the assessment of the verification checkpoint to think of ambiguous situations. For instance, when we have echotones. If my verification checkpoint is in an ecotone, it means that there are different categories that might be acceptable as real evidence, as real truth. Ecotones could also be temporal. If I have a mosaic of 1,000 plants or vegetation or grasslands or primary forest, there's a lot of ambiguity for me to know if it's become an abandoned grassland has become a macawal or some other type of land. And we have another confusion when we think of the fragmented landscapes, with small fragments that are below the minimum mapping area.
So if here we handle a binary truth, let's say the category that the verification site reads and the category the map reads, and if there's not an accurate matching, the mapping would be mistaken and the quality of the map would be also undermined. So I have to use mechanisms that are not very flexible. We need to set the limits of the mechanism in order also to flexibilize the subjectivity present in the construction of a map in a given territory. For example, thinking of a very dynamic territory as the Mexican territory. And finally, we have the estimation of reliability indexes. Here the point is to do some estimations in order to compensate the difference of sampling efforts. It's the rule of the third. It's simple equations, but unfortunately not everybody performs these equations. And here we have indexes that provide us information on the global quality of the map, and there are some other indexes that take into consideration commission errors, and they give information on each one of the categories of a map. And finally, well, something that's also very important, this exercise of reliability evaluation talk about the estimations on different surfaces. So here, for example, this is a summary. We need to correct bias related to sampling, and based upon that, we will come up with the corrections both of reliability indexes and of area estimations. For example, the majority of commercial software, what they don't do the estimation taking into consideration the type of sampling. Let's say when I use an IDRISI and you use AirMap and the confusion matrix, depending on the sampling, reliability indexes that the software provides can be mistaken. So along with the University of Guanajuato, we developed a tool, a very simple tool that makes the corrections in a very simple way. This is an example of that application. It is a map of using and land coverage. We checked 110 sites with a stratified sampling by category in the map. And you can see here that category 2 has commission errors, so the map tends to see more categories. Things that are not a category are mapped as if they were a category. So when the map allocates category 2, it is always category 2 in such a way that here category 2 for this map is overestimated. If we calculate the surface area directly with the map, this category covers more than 15% of the map that's been covered. And once the correction has been made, taking into consideration the errors, we see that we have here 10% of the surface. But this estimation is based upon sampling. If I want to have more accurate data, then I would have to do a bigger sampling and use more verification sites. As a conclusion, despite the fact that we've been working on reliability verification for more than 3 decades, this type of exercise is not widely practiced. It brings many advantages. There's a lot of information that we can extract from this type of exercise of reliability verification. One of the contributions that we can make is to create tools that allow us to do so without having to do many equations. This is a tool that allows you to do accurate estimations without being an expert on statistics. And my final slide. This was my final slide. Thank you very much. Dr. Mas, thank you very much for your participation. And now we'll have room for questions and answers. I think you already have your papers. I'm just going to read a couple of questions because we're running out of time. So here, Francisco Montes from Instituto Politécnico Nacional asks, when we're working with urban cartography, and let's say that we make a collection on elements, in this case electricity poles, we know that they need to be located by an avenue. So what are the algorithms that need to be used in order to do this automatically, and how to deal with the requirements that needs to not disclose this information? Sorry, I was not putting attention when you read the question. Well, now the following question, because this question was rather confusing. Joel Tobar Velasco from Cuauhtemoc Borough in Mexico City. What are the recommendations to have a project similar to the Spanish one? From the municipal level, we are willing to collaborate, so what do we need to do? Well, what you need to do is to be patient. You need to know where are you going. If you know where you're going, the United Nations, what they indicate, what they've been indicating these years, this needs to be produced once, the project needs to be sustainable, and you need to reach co-financing, because you need to put all the parts together since the very beginning. And if you don't do this, everything will lead to disaster. We achieved something that looked impossible 2 years ago when this activity started. Normally, public institutions are individualistic. They say, I don't need anyone to do the job, and that's how they act. They're pretty selfish. So this kind of philosophy always leads to chaos and failure. You need to get everybody involved and have everyone on the same page so that to move on for future decisions. One more question. Carlos Roberto Lopez, and this goes for Dr. Arosamena. Geospatial information pointing to sustainable growth. Can you give us precise examples on how this is helping? And can you give us indicators? And I also have a question for you. If no one poses that question, it would be myself in making the question. But first, I need to answer my question. Regarding sustainable growth, well, I do buy that idea of sustainable growth. If you don't buy the idea, then it is impossible to convey your thoughts to anyone. The motor of change, in order to make projects to be collaborative, you need to use an international policy, and we based everything on sustainable growth. We read the mandates on sustainable growth, and we also read the Millennium Goals by the United Nations. And we identified the motors of change from our perspective of geospatial information, and we relate those that made reference to economic and sustainable growth from a geospatial perspective. And we had a lot of things to do with regards sustainable growth. We have the General Secretary of Geo around here, somewhere around here, and she will pronounce a presentation on geospatial information in sustainable development. She will explain this in a better way. But all the ideas regarding geospatial, regarding sustainable growth, need geospatial information. The agro policies, the PAC from the European Union. I'm talking about policies of more than 5 billion euro. This is not little money, and orthophotography is receiving a lot of funds from this initiative. So if not everyone is on the same page, you won't receive help. And cadastre they also need to identify the buildings. So you have all the information you need on a permanent basis towards sustainable growth. Cadastre and taxes, all that contribute to economic development. Right now we're dealing with climate change, ozone layer holes. Well, we need to pinpoint them, and sometimes they locate above forests. So reference geospatial information is of utmost importance. Without it, we wouldn't been able to make any progress pointing to sustainable development. Now we're running out of time. It's your turn to pose your question. Well, I totally agree with everything you've said. How to make theme information without knowing the accuracy and the level of trust. And you've explained this in a very clear way. I totally agree. But at this point, I'm tired of hearing that accuracy and precision of information at some point is useless. I'm more dramatic than you are. Without accuracy values, it's like I'm not gonna place somewhere where I don't know what's the accuracy and what's the precision level. But there is something that you didn't mention, and that in my case would make invalid all the information that you've mentioned. Geometric precision or accuracy. Why do you only talk about, and this is something fundamental, that line that divides polygons and parcels? How did you collect that information? I can assure you that based on the geometric information of those polygons, because no one pays attention to geometric accuracy and is as important as thematic accuracy. So are you also taking into consideration the geometric accuracy of polygons? Well, this is a very tricky kind of question. Yes, somehow geographic information has two sides, the thematic error and the geometric error. Let's say if a polygon has erroneous attributes, or if the polygon can have the right attributes but maybe not the right limits. But conceptually, both can be divided. A polygon that's halfway mistaken, well, what's the nature of the mistake? Is it geometric or thematic? When it comes to do evaluation exercises, you need to make the separation between these two types of errors. And to me, this is very confusing. If you have a sampling on verification sites, well, somehow the sites that are close to the borders maybe can give us a mistake of more geometric nature. The thematic can be the victim of geographic errors, so to speak. And for example, talking about the ecotones, it's precisely that. There again, we have a certain, or we need to handle this in a more flexible way, both the thematic and the geometric error. An ecotone, in the end, what it is saying is that for certain categories, there is no line that crosses through here, is more a gradient. There are some other categories that do have a limit that can be categorized in a more strict way. Let's say the line crosses through here. A street has a sidewalk and there are no ecotones for the sidewalks so far. So then, likewise, we can also deal with thematic flexibility. A pine wood or an oak wood can become pine when you have too many pines instead of oaks. To me, the difference between the two errors is not very clear to me. But I would also like to say that to some extent, the default perception of things that I have is rather different, but it also relates to this topic. What I mean is that from top to bottom, the producer of the map is the specialist, INEGI, let's say, and they are going to make their own evaluation on reliability. But it would be also very interesting to see what would be the consequences of a more bottom-to-top approach. Let's say that for some exercises you use information coming from the community to elaborate maps, and so that those maps were elaborated from a more centralized institution. Well, I'm so happy to talk with an advocate of this type of perception. I'm going to give you an example. Let's think about a large scale. Let's talk about 5,000. The community area policy, which is a 5,000 everything. Let's imagine that you classify both at a human and an automatic or semi-automatic level. You classify within a parcel, and I'm talking about 5,000, but we can use it to at a 200,000 level. So let's say that you identify tomato in this parcel with 95% of probability, and that parcel is not yours, but it belongs to the guy next to you. So the exact geometric division of parcels maybe is remarkable, and I'm not talking about ecotones or the transitional hills. That line is not worth money. The lines that are worth money, the ones from the landowners that are worth money, and if you're having a precision of more than 90% of reliability, which is the standard that we use in the European Union. So when you're talking of something that is in this level, then it's something that's really worth money. Thank you very much for your comments. And finally, on behalf of INEGI and the United Nations, I want to give you a token of our appreciation to thank you for your participation.